All right, we're going to end up cutting that part out. That was a lot of information there. Testing, testing. All right, cool. So today I'm going to do a Demux, or reprogram the Gmux on a MacBook Pro 15-inch 2011 that has a failed graphics card. Now this is a little bit more of an advanced repair, and I only recommend people who have experience with micro-soldering as well as flashing firmwares on ICs to do this repair. This is not going to be just a quick little patch job where we pull the logic board out and put it into an oven like some people do. I highly recommend not microwaving or baking or using any type of oven method to heat up your logic board. The theory is that there's bad solder joints on the graphics card, but it's actually the substrate built into the AMD graphics processor that tends to fail. And whenever you heat it with a lot of heat, whether it's with a heat gun or an oven, you kind of temporarily fix what's wrong with the substrate inside the GPU die, which makes people think that it's actually an issue with corroded or oxidized solder balls, but that's actually not the case. So this is just going to be a quick little live stream on how we actually do a Gmux flash, Gmux firmware flash. I'm going to do a more in-depth video with some links on where you can actually get this done. This information was created and provided by Colin, or Dosdude1 over at Doslabs. Him and his partner spent a lot of time figuring out how to do this. Highly recommend supporting Colin at Dosdude1.com if you're interested in doing this repair yourself. So right here, I have myself a 15-inch 2011 MacBook Pro, and I've already figured out that the GPU itself has failed, and how we did that was the computer will turn on. However, if I run a benchmark such as Valley by Unigen, the computer will just shut down. Or I think in some instances it actually would have like purple lines going through the screen and then shut down. So that's all the symptoms of a failed graphics card. There was actually a recall on this specific computer that lasted until the end of 2016. Unfortunately, that recall is no longer in place. So if you have a failed graphics card and you go to Apple, they're just going to tell you to buy another computer or charge you for the price of replacing the logic board. Well, here's the thing. If you replace the logic board with another 2011 logic board, I can almost guarantee you're going to have the same issue. So one resolve is you can upgrade the logic board to a 2012 logic board, and the computer would actually be able to run Catalina, Mac OS Catalina just fine, which is actually an upgrade from the 2011, which can only go to High Sierra. But there is a caveat to that. It is expensive. They don't make replacement logic boards anymore for this specific model. So a 2012 MacBook Pro logic board, I think last I checked, was still going to run you about $500, $600 just for the board alone. So, and we can see this one has actually already been repaired once by Apple. Normally the RAM slot has a serial number on it, but once it's been serviced by Apple, they actually remove the serial number and just put a blank spot basically over it. In some instances, when we look at the GPU, we can actually see where Apple themselves have attempted to reflow the GPU. And let's see if they did that in this case. Usually the components look a little yellow. And fortunately, they did not do that in this one. It looks like they just ended up replacing the board rather than trying to overheat it, with the theory that the GPU solder balls would basically go back in place. So thankfully that wasn't done here. So I'm just going to go ahead and dive straight into it. This is our Gmux. The Gmux is responsible for sending power between the integrated graphics and the dedicated graphics. So if we actually go over here onto our board view, let's pull up a U9600 is our Gmux. And it's a very important IC. We can see that it's actually referenced many times in our schematic, but I want to find the actual IC itself. Here we are. All right, and the Gmux is responsible for a couple of different things. Let's see. This is all going to be data lines and clock lines to the LVDS, but I want to see where the actual power lines are going to come from. Let's see what else we got here. LCD backlight enable, display port mux enable. So we have an LCD line, a display port line, GPU vCore enable. So this is going to be the power supply, you could say, for the graphics card. Everything that does with graphics, the Gmux is responsible. So what we can do is, if we look over here on our board view, there's two different ICs. The U1000 is going to be our CPU. This is going to be either the i5 or i7 processor based off of which model you have. And then here's the AMD graphics card. So what we're going to do with the Gmux is reprogram it to just completely sever ties to the failed graphics processor. Only use the Intel processor with the dedicated graphics card. So this essentially is going to turn into a 13-inch MacBook Pro. Now, there are a couple of caveats to this repair. One, the external display is controlled by that AMD graphics card. So if you use like an external monitor through the Thunderbolt 2.0 or mini DisplayPort connection, it's no longer going to work. Also, brightness control doesn't natively work. There fortunately is a new patch to where we can tie a jumper wire down to our battery light indicator to where we can actually control the brightness using the button that tells us how much battery is left. But native backlight LCD backlight control is also somehow tied into the integrated or dedicated graphics card. So when we disable it, we also disable the feature for the brightness, but fortunately there is a way around that. So if you don't use an external display and you don't really mind this extra mod for the brightness control, then this repair will probably be enough to get you by. Us personally, we offer this as a service for $150 versus for a 2012 logic board replacement, we used to charge customers about $650 to $700 depending on how much the board was. So that just wasn't a viable option anymore, especially for a computer that's 9 years old and only gets High Sierra, which in November 22nd of this year, 2020, will no longer get security updates. So it seems to be a good band-aid just to get you by for the time being, so you don't spend $2,000 to $3,000 on a brand new MacBook that may or may not have issues with a T2 chip. But how do we do this repair? So how do we program the Gmux? We can't just plug in a USB port and just simply code over data. If you look right here, this actually is, we can call it a developer Jtag connection. And from the factory, Apple, pardon me for a second, I'll be right back. Just had to talk to my wife real quick. It's a little late in the evening, so just wishing me a good night. All right, so back on what I was talking about is over here on our board, we can see that there is a developer Jtag connection. So I've actually spoke with Colin, and he actually sent me a link to where we can find the replacement parts for that, or that Jtag connection itself. So we can actually get it from Mouser, and I'll leave a link in the description, but it's actually just a standard Molex, let's see, it's just a standard Molex header with wire housing, and I have a surplus of them here specifically for this repair. Now we're also going to need a programmer, and I think in this case it's a TL86 2. Let me see if that is correct. Yep, we're going to need this right here, the XGECU Pro. This one here is a TL8662 Plus, as well as a header with the wires. And this one I've already pre-soldered to the wires itself to do this specific repair. This is the wrong programmer. I'm sorry. Hold on. Disregard what I just said. And this is why I'm doing a live stream, just so that I can kind of chop this down later, but I'm going to do a more in-depth video. What you're actually going to need is a lattice. And this programmer specifically actually has the connections we need for programming the Gmux. Let's see if we can get that in view. We got VCC, TDO, TDI. Come on, pay attention. Well, the camera's trying to focus, but it's not working. So you can actually buy this header right here from Mouser directly, and this is the header with the wire as well. And we can see right here in the packaging, this is going to be the part that plugs into our Jtag connector. Now, before I ordered that part, I'd actually already just made my own using some jumper wires here with the header on top. So I'm going to begin the process by going ahead and solder on a Jtag connection onto where it used to be in the developer option. So let's go back to our microscope camera, and let's put this at an angle to where I can see for working. All right, and let's get started. Let's turn on our fume extractor. And of course, if you're doing this, make sure to have the battery unplugged. So now I will need my Jtag connection itself. All right, here it is. And you can see it's just going to line up perfectly on where those pads used to be. Or, well, the pads are, but where the Jtag used to exist. Now we're actually going to have to solder it on. So for this, I actually use my micro pencil with my knife tip specifically. Let's turn this more at a better angle. Okay. And that beep was that my pencil is ready to go. So now we can just go ahead and touch one side and apply some solder, and it should grab this leg right here. And it might take a second just because these pads in particular on this one are actually a little bit oxidized. All right, so I got one on, and now let's kind of catty corner it and go to the other side. Alright, so let's work on this one. Since these pads are a little bit more oxidized, I gotta let the solder sit there for just a little bit longer. Okay. Got 4 of the 6 soldered. Five, and then the last one. Okay, perfect. Now that we have all of our 6 legs soldered, we're going to also have to put a little bit of solder on our standoffs just for structural integrity. So it's a little bit trickier here, but basically you just got to wedge your knife, if you have a micro pencil, just right along the edge while also feeding it some solder. And it's going to melt slower just because ground naturally dissipates heat faster. It's almost like a heat sink. And see, my solderer is actually not really getting onto it. I'm trying to get it onto the soldering iron before it starts to melt the plastic. Okay, and it feels like I got that side on. Now let's move on to the other side. And this is where it's just a little tricky for me, just because I have to kind of bend the angle differently. All right, and then just to make sure that that is actually in place, poke it. And it's moving, but not a lot. Let me touch up this one side, and this is just basically going to hold the wire for the Jtag in place. Cool. And we're intact, so let's clean up this area. And our Jtag connector is in place. So now we'll actually need to connect it with our wire. So now that that is there, and you have your wire already pre-made, we will plug this like that. So now we are ready to program. So, before we go ahead and program, very, very important, make sure you unplug the SATA cable that goes to the hard drive. That way, the computer is going to turn on and off a couple of times. When you do this, you don't want to potentially corrupt any data, and you also want to make sure that the battery is unplugged. So now, we will grab our Lattice programmer and plug the cables into the, what would you call that, blowout or pins in itself. So now we're going to connect the USB type B into our computer. So we got a red light. We got to wait for this to actually turn on green. So what we'll have to do next is get the license that Colin sells over at his website to actually run this instance. It's only $20. Support the repair community. If it wasn't for the just sheer passion to get devices working again, this would not exist, and we would not be able to have these computers working the way that they are. So what we have to do now is actually purchase the license. Now I'm going to do this on my personal computer just because I don't want people to try to use my license, but I'll show you real fast how you go about it. So if we open up a new tab and we go to Dosdude1.com, there's a section for resources, and under resource there is Demux, permanently disabled the 2011 15-inch and 17-inch MacBook Pro dedicated GPU. Now, I won't go into too much detail here just because I'm going to make a more in-depth video, but basically this goes into detail talking about how to purchase a license key, how to download the actual program that we're going to use here. If you don't have access to the Jtag connections, you can actually just solder wires directly onto where the Jtag goes. This method I find to be a little bit more time consuming, so it's worth it just buying the Jtag ports in my opinion. Here's for the 15-inch, here's for the 17-inch, and Colin even made a video basically explaining how to do it yourself. I just wanted to go ahead and pretty much show how we do it. So what you would do is click on purchase a license key and then just type in your information. Now I'm not going to do that here on this computer, I'm going to do it on my personal computer just because I don't want this information you could say leaked. So for now I'm going to just leave this here while I purchase a license key on my personal computer. And looks like I just got a lot of emails that came through over here. Like I said, it's only $20, and honestly, I feel like it should actually be more than that. Looks like that Colin offers that as a service for you to mail it into him directly. It's $60 plus shipping, or $40 if you've already bought a key. So it's going to come out to about $60 plus shipping anyways if you send it out to him. But you can also do this repair yourself if you're a more advanced technician who has access to micro-soldering equipment. If you've already bought the Lattice programmer and you just know a thing or two about programming the firmware on ICs. All right, almost done on my end. Once you've made a payment, you will then get an email that pops up with the email address for your PayPal account that has the license key that you will use in the software necessary for the repair. And so I have my license key already, and I'm going to just save a copy of it real fast. Okay, and my license key, it just came through. I'll just save it on my computer. And now with this still being closed, let me go ahead and put it in my clipboard. Okay. And we're safe to view again. All right, so I've already purchased my license key, so now I'm actually going to have to open up the software that you can download from Dosdude1's website. And let's see, I already have it saved under a file called Demux. The application is Demux. And then right here, we get to type in our license. So before I do that, the next step is going to be to plug in an Apple original 85-watt charger. You can't really do this with a 45 or 65 watt because the battery's unplugged. So it has to be Apple original, not a Chinese knockoff $20 Amazon charger that says it's 85 watt that's actually only putting out 50 watts. It has to be Apple original. So I have my charger. I'll plug it in real quick. And what's going to happen since the battery has been unplugged is that these fans are going to spin twice, and then we will hear the chime for the computer turning on. It's not going to boot into an OS because we have the SATA cable unplugged. So there goes the second fan spin, and here comes the chime. All right, chime is there. So this has now turned green, and this is ready to be programmed. So now we go over to our on screen and we're going to just paste in the license key real quick, click on apply. It says license key is invalid because for some reason it copied 4 extra characters. Let's apply again. All right, it's good. So now the next step is to just flash Gmux. So we're gonna let this now talk to the Gmux via our our Lattice programmer and the Jtag connection. It looks like it is preparing the firmware, and then here in a second it should actually start flashing the Gmux itself. Alright, it is now flashing the Gmux, and this always pops up asking if you want cable server to connect. Just hit allow access. Alright, once everything works, the license will become consumed. If for any reason it failed, it will then say that the flash failed and the license is still valid. But it went through, so this works. So now, let's go ahead and switch back over to the overhead camera. And let me pull up some things here. Alright, so now we can just go ahead and safely unplug our MagSafe 2. The computer has turned itself off. This is turned red again. Now we will unplug the wires for the Jtag connection. And I'm going to actually leave the Jtag connection on just because you never know when in the future you may have to actually reflash this back. And also this kind of works as a warranty sticker, you could say. If you open this up and you see that this has a Jtag connection, you know that you've done a Gmux repair. So the computer itself will boot up. But we're not quite done. There's an extra step we're going to do now because we have now permanently disabled our brightness control. And brightness is pretty important, especially in dark environments. So how do we fix this? We can run a jumper wire between our, I want to say it's a Gmux VSync and our Bill backlight low connection. Let me just go ahead and open up my screen real quick just to show you exactly where that is located. So on the other side of the board, next to the Gmux, there is a Gmux VSync where R9670 would exist, but that is a no stuff. That is completely empty. And what we're going to do is run a wire from there all the way down to our SMC backlight, or I think that is battery indicator light button low. So whenever we press the battery indicator light, it is going to then send a signal or drop our Gmux VSync right here to ground, which will then change the brightness of the display. It's a really cool mod. So let me go ahead and grab my jumper wire and get this part started. Let's see, where are you? There you are. So that resistor, which is a no stuff, we are just going to tin up that area. Alright, so I'll grab my micro pencil. And now that area has been tinned, and now we're going to go down to our backlight, I'm sorry, I keep saying backlight, our battery light indicator, and we have a capacitor right there. So we are going to just tin up that capacitor real quick. Alright, and now we are ready to start running our jumper wire. Now, let me grab my jumper wire. And since this is a capacitor, we want to make sure that the wire doesn't bridge both sides of the capacitor together. Okay. And now we will take our wire and we're going to apply some mask to hold it down in place as we continue onwards. So mask is going to be a UV reactant hardener. So what we do is we just line it where our jumper wire is going to be angled and bent, and we're going to hit it with a UV light to cure it. You don't want to look in the UV light directly, it's actually bad for your eyes. For all I know, this actually might be damaging my, my camera. Okay. And so let's test and see if that hardened up. Yep. Alright, so that's holding down in place. And let's continue. So I want to put another piece right here. And so for this one, I'm actually going to hold it in place. Watching a video on someone using UV light is not dangerous. It won't transmit through the screen. I don't know. It's called Real D. Okay, and so now that's holding the wire in place right there. And now we need to move our wire this way, and it looks like it actually just popped off. I moved it too much. Okay, let me try this again. And 1 second, let me actually get my plunger real quick for this. Okay. Okay. And now we have to start routing our way up this part of the board. And what I'm trying to do is avoid any pads, just so we limit the chance of potentially running our enamel coated wire into another part of the board that doesn't need to be contacted. I'm just making sure that wire down there is not touching the other side of the capacitor, so we still look fine right there. Continuing onwards. Been saying that a lot lately, don't know why. I'm gonna put another spot in between here, just to hold this taut. Alright, now we're almost near the end where our jumper wire will actually connect to our what am I trying to say? That resistor point that's not connected and no stuff. Okay. So we have now successfully ran our jumper wire. Let's just go ahead and remove our excess wire. Finish curing some more spots and test this out and call it a night. Okay, so that side's good. Let's walk on down here. And we had a little bit of a wire right here that we no longer need, so let's see if we can cut this free. Okay, that looks good. And let's touch up to make sure that there aren't any potential loose ends. Yeah, see, like right there, that looks like that needs to be fixed some. Right there is okay. So let's put a dab here as well as a dab there. Put a pretty big dab actually right here just to hold it in place. right. Now let's just start heating up those. Alright, not heating up, I'm sorry. Now let's just start using our ultraviolet light to go back and forth and heat. I keep saying heat, I'm sorry. Let's use our ultraviolet light to start curing the resin of our mask. And so I'm just going to let it sit on here for probably a good 30 seconds to a minute. All right, that should be good enough, but let's take one more look. Yep, that's all hardened up now. And let's clean the last little bit of flux that was left behind right here. So the Jtag connector, accompanied with the jumper over here, is going to be more than enough indication that you have serviced this board, or that it's had a Gmux replacement, repair, a reflash. So let's put our battery light flex into its connection. And let's put our wire away for the time being. And what I'm going to do, just to limit potentially exposing any customer data, I'm actually going to boot into a test operating system just to show you that we have removed the card. Oh, also, the last thing we can do too, there is one resistor that sends power to the GPU that we can remove. And let me see which one that is. It's over here around U8900, and this is going to be our GPU V-core regulator. And the component in question is going to be R8911. If we remove R8911, we are going to be severing PVCC from the rest of the GPU. Now, you're probably asking me, why didn't we just remove power in the first place? There's just so many issues with removing power from the dedicated graphics card without flashing the Demux. Gmux, I'm sorry. You actually can cause issues that will prevent the computer from powering on entirely. That is just, unfortunately, a lazy man's way of removing the power to the dedicated graphics card. You have to do a flash on the Gmux before you can do this method. Now, once I remove this resistor, power to the GPU V-core, which powers the dedicated graphics card, is going to be severed. And the main purpose we do this is, one, it's going to cut down on power consumption, so the battery life will actually last longer, but two, the graphics card's not needed since we have just permanently disabled it using the flash. So by removing the power to it, it's not going to get hot, so the computer will actually run cooler. So let's go ahead and go back to our microscope and find that resistor, R8911, and that should be over here. Let's see. R8911 is going to be at the top of our R8900, or our U8900, I'm sorry. So for that, it's going to be that tiny, tiny little resistor that's right next to all that dust. For this one, since it's just resistor on both sides, we actually don't even need flux. I believe this whole thing should come right off if I had my tweezers plugged in. All right, wait for a beep. All right, so now we should be able to grab this and pull that right off. No longer needed. If we want to, we could just touch up that pad so they don't have mounds. And then make sure that that's severed. Yep. All right, that was the final step. So, did this work? Or, oh, that camera. Focus. All right, so you might be wondering, does this actually work? Or did I just do a whole bunch of voodoo for nothing? Let's keep the HDMI, I'm sorry, let's keep the HD cable, the SATA cable, unplugged because I'm actually going to boot into one of our test drives. So for that, I can actually plug the battery back in. We'll push this up. And let me go grab a test drive that has High Sierra on it. All right, and let's go ahead and turn this on. It's probably going to take a second since the battery was unplugged, so it's going to boot twice, maybe 3 times, until we hear a chime. Okay, there goes the chime. And now I'm just option booting. Time for me to turn on my test drive. And since this is a 2011, the highest operating system it will go to is High Sierra, so we're going to boot into a test High Sierra. Now I just wait for this to boot. We're booting through a USB 2.0, however this is a solid state drive, so it should boot fairly quickly. It should boot fairly quickly for USB, I should say. USB 2.0 still only transfers at speeds of 480 megabytes per second, versus USB 3.0 I think is 5 gigabytes per second. Maybe gigabits. Bytes, bits, I always forget the difference between the two. But it looks like it is turned on. So now I'm just going to boot into it. It's a little hard to do it upside down. But it's loading up now. Alright, so the computer has booted up. So first thing is, let me show you what I was talking about with the backlight. I'm going to press the backlight button, and if we drop it down all the way, let's see, all the way, and it's still at full brightness. We're going to turn it up all the way up, and it's still pretty much at the exact same thing. So the battery light indicator mod is going to allow us to control the brightness. So when I press this button, you see it's dimming. So each time I press the button, it's going to dim it probably about maybe, I'd say, 10%. So it's completely turned off. I'm going to hit it one more time and turn it back on. So this way the customer still has brightness control, and it's a really cool way of showing people how your Mac works. So just by pressing the backlight, the battery light indicator, we can now control the brightness. Now, if we go to About This Mac, I'm blocking the serial number there for a second. I'm going to go into System Report. And I'm going to go to Graphics. All right. Now, it's a little hard to see from this far away, but it's only showing one graphics card. Let me see if I can kind of pick that up. And it's upside down too. But it is only showing the Intel HD Graphics 3000. Normally, in this model, it would show the AMD graphics card, but it's only showing one card. So we have successfully flashed the Gmux to say the AMD graphics card no longer exists. We've even removed power to the GPU V-core, which actually powers the dedicated graphics card. So now it's no longer going to turn on. The computer is actually going to run cooler. On top of that, we've run a wire from our Gmux to the battery light indicator, to where whenever we press our battery button, it is going to dim the screen. Like I said, it goes down about 10%, and then once it's all the way, it turns back on. This computer now has life. It's not the perfect fix, but in my opinion, it is the best that we're going to get. The computer is now a glorified 13-inch. It's fully usable, though. You can actually still do Photoshop in this. It's probably not going to perform as well as it did because you are removing the dedicated graphics card. However, this is a permanent fix. It's a fix that will last. It's not a fix that will only last for a week and then stop working, kind of like the throwing into an oven and pretending it's pizza for about 20 minutes. This is an actual advanced repair solution that Colin, or Dosdude1 I should say, has reverse engineered himself. This is amazing in my opinion. I cannot imagine doing this. I actually went to school for computer programming, and just the idea of reverse engineering Apple's information with no documentation is a feat of itself. So for that, I definitely commend Colin for his work and trials and tribulations. So that is how you properly and successfully flash or repair a failed GPU. You're not necessarily fixing the GPU, but you're patching it to get the computer somewhat usable again. So just to show again, everything's working. One card, not two cards. The computer itself just kind of dimmed itself because it timed out. And if I press this button, it now controls the backlight. Really awesome option to offer customers. If you're trying to get this done for yourself, you should only do this if you have the equipment necessary. At this point, I'm just rambling, but this is an extreme warning for anyone interested or watching this video that you should have experience. Don't be someone without tools or equipment just trying to do a quick little patch job, because this video or this stream itself, let's see, how long have we been going here? Almost an hour. And I'd like to consider myself a seasoned technician, but if you've never done this yourself, it may take 2 hours, maybe 3 hours. But you have to have the right equipment. I've shown you the resources on where you can figure out all this information. I'm going to have a better video with links in the descriptions on where you can purchase the parts yourself, but that was a quick little live stream on this. So I appreciate you all for joining me tonight while I just show the process of repairing a 15-inch 2011. The same process works for a 17-inch 2011, but I'm just going on at this point. Thank you so much for joining me, and I'll see you guys in the next one. Bye.